Hello everyone, welcome to my YouTube channel. Today we are going to see the introduction to additive manufacturing. So what is additive manufacturing? Additive manufacturing is basically a process to add the material in a layer by layer manner to generate the final product. So as the name suggests, additive means addition of material. Supposedly you have to make a cube. So this is a cube. So now generating this in a layer by layer manner, like generating this much layer in one go, then this height of the layer in second go, then this height of the layer in third go, this process is termed as additive manufacturing. Other synonymous terms for additive manufacturing are 3D printing. As the name suggests, this is printing in 3 dimensions, thereby creating solid objects. So additive manufacturing and 3D printing can be used interchangeably. 3D printing is used more commonly by the general public or the common people, while additive manufacturing is more suitably a technical term. Another term that is commonly used is rapid prototyping. But rapid prototyping differs from additive manufacturing or 3D printing. Rapid prototyping is basically an application of 3D printing or additive manufacturing. So rapid prototyping, as the name suggests, it is prototyping very rapidly. So additive manufacturing is a technology using which rapid prototyping can be implemented. So this is a technology, whereas this is an application or implementation. So why use additive manufacturing? We have certain advantages to use that. So first and foremost comes the highly complex geometries that can be made with ease using additive manufacturing. All we need to do is just to supply a CAD file or a computer-aided design file. So as you can see in this first image, these channels or these topologies are difficult to be manufactured by conventional routes. Or if you say by CNC milling also, this is very difficult because these internal channels cannot be created easily. In the second image, this is a gyroid type of structure and it incorporates lattice structure on its surface or some kind of porous structure. So using 3D printing or additive manufacturing, this can be implemented really easily. Next is material complexity or functionally graded materials. They can also be generated with ease with additive manufacturing. So what are functionally graded materials? In very basic terms, we can say functionally graded materials are those that have a variation in properties along their dimensions. For example, if you have this cuboid, say its properties varies from this end towards this end. Supposedly say its stiffness is increasing as you go from one end to other. So you can say this is a functionally graded material. This can be achieved using additive manufacturing. Or also you can have multi-material components. Say for example, in FDM 3D printers or fused deposition modeling 3D printers, we have dual extrusion printers. So these are capable of extruding two different or same type of materials simultaneously, giving us a multi-material component. Next, this is a green manufacturing technique. Adds to very less wastage of material. Since material is added and not subtracted, so there is no wastage of material. Wherein in certain cases there is very minimal wastage where powders are used as the raw material. There, some of the powder is affected by the heat that is applied to fuse the particles. Otherwise, there is very minimal wastage because of absence of subtractive technology. Next is much reduced lead time and time to market. This technique enables us to prototype or to check the objects that we want to build at a very initial scale by prototyping or making smaller scale objects using additive manufacturing. So this saves us with the time of actually manufacturing a component and then testing it. So as a result, we have early launch of the products. Next is easy prototyping and testing at the concept. Supposedly, you want to make a spanner with an improved design. So you can easily form the CAD model of the spanner and easily make a prototype using additive manufacturing and then test it at the concept instead of going through the whole lot of manufacturing process and then testing it. No assembly requirements. So here you can make assemblies in one go without actually going about making individual components and assembling them. Zero scale manufacturing technique. All you need to do is to supply a CAD file to the printer and the printer will print that thing and you will have your object or the final part. Printers these days come with preloaded instructions, so you can go about having default settings and print the object. Obviously, if you need more precise control over the parts or the objects, you need to play with the process parameters and everything. But the default settings makes that a zero scale manufacturing technique. Next is precise replication of the 3D CAD model. So this is a very precise technique. Its precision ranges from plus minus 0.1 mm for FDM to some microns for industrial grade printers. So this is for like very basic desktop printers that are commonly available these days. And these are some industry grades that can offer such high precisions. Now let us look at some applications of additive manufacturing. So biomedical applications. Biomedical implants or your dental aligners, these are being developed using additive manufacturing. So you have implants like titanium implants can be produced using metal additive manufacturing. Then you have dental aligners that uses additive manufacturing. These days organ 3D printing is also being done. Also skin 3D printing is also being researched. So there are a whole lot of biomedical applications. Next comes automotive applications. So in automobile industries, this additive manufacturing techniques cuts off the tooling requirement. uh, it allows for making of jigs and fixtures, and also certain car components these days are being made of additive manufacturing. So the seats of racing cars are being developed using additive manufacturing, and certain outer panels or outer coatings are done using additive manufacturing techniques. Next is jewelry. So very precise designs or very intricate shapes of jewelry are being developed using additive manufacturing, because it is very difficult to make such intricate designs using conventional methods. Then electronics, PCB printings, etc. are done using inkjet 3D printing. Textile industries, so fibers are being printed. Aerospace industries are there, making of conformal cooling channels or optimizing the topology to reduce the weight, because weight plays a very major role in aerospace industry. So additive manufacturing helps in that way. Sports equipments like certain helmets or that protective gears are made using additive manufacturing. Construction or concrete 3D printing, this have seen recent developments. So there have been reports where one room or a house was built using 3D printing, and one of the institutes also has built certain stools or vases using concrete 3D printing. And obviously there are defense applications where armors or protective gears, armors are made using additive manufacturing technique. With a whole lot set of advantages, we have certain drawbacks of additive manufacturing as well. First is lack of industry standards. Since it is a recently developed technique that has been worked from over 2 to 3 decades, industry standards have not been set up as of yet, because there are multiple parameters that can be changed, that can be optimized. So there are no specific standards as to what parameters should be kept to attain certain mechanical properties. This is not suitable for mass production because it takes time to produce one single object, although at a larger scale, if we see, it reduces the time because we have reduced tooling requirements and the product can be built in one single go. But we cannot have multiple products being printed at the same time unless we have large number of 3D printers. Then limited number of materials. See, we have polymers, but not whole lot of polymers can be printed. Metals and recently developed ceramics. But not every material can be 3D printed. It needs to have certain set of characteristics. High cost of the precise equipments. Very precise equipments cost somewhere starts from ranges in lakhs and can go up to crores. And unexpected pre and post processing requirements. Like for fuse deposition modeling 3D printing, if your filament is brittle, then you need to heat treat it so that it goes into the ductile range again. Or post processing, like certain heat treatments are required because of the residual stresses that are developed. These residual stresses are developed because of alternate heating and cooling cycles. That the product or the part needs to undergo during the 3D printing process. So with certain benefits come certain drawbacks as well, but overall we are benefited with this additive manufacturing technique and hope to see more of it in future. Thank you.